Welcome back. In front of us, we have a question that reads, a body weighing 160 newtons moves with a speed of 8 meters per second in a horizontal circular path of radius 3.2 meters. Calculate the magnitude of the centripetal force acting on the body. Solution: the weight of the object is 160 newtons. The linear velocity is 8 meters per second. The radius is given as 3.2 meters and gravity is given as 10 meters per second squared. The question is asking us to find the centripetal force F. So one thing I would like to remind you about is that the weight of the object is not the centripetal force, but we can use the weight of the object to determine the mass of the object. Okay? So using weight is equal to mass times gravity. If we want to find the mass of the object, we will divide both sides by g. So this will cancel this. Therefore, the mass of the object is equal to the weight divided by gravity. The weight of the object is given as 160 newtons divided by gravity is 10. So which means the mass of the object is 16 kilograms. So after knowing that, we will try to find the centripetal force. To find the centripetal force, we either use the formula F is equal to mv square divided by r, or F is equal to m omega square r. So if you look at the parameters that are given, you will realize that the linear velocity is given. So it is easy for us to use this formula to find the centripetal force because the angular velocity is not given. So which means if we want to use this formula, then we will first have to find the angular velocity. The choice is yours. So going by this formula, F is equal to mv square over r. That will be F is equal to the mass of the object is 16 times the velocity is 8. So that will be squared divided by the radius is 3.2. So that will be F is equal to 16 times 8 square is 64 divided by 3.2. So F is equal to 16 times 64 is 1024 divided by 3.2. F is equal to 320 newtons. Okay, so this is the answer for the centripetal force. But what if we wanted to use this formula? F is equal to m omega square r. It means we will first have to find a way to find the angular velocity. You don't have to show the alternative, but I am just trying to show you here how you can get that. Now, using V is equal to omega r, if I want to find the angular velocity omega, I will divide both sides by r, right? We agree on that. So the r cancels, which means omega is equal to V divided by r. So the linear velocity is given in the question as 8 meters per second divided by the radius is 3.2. So 8 divided by 3.2, you get 2.5. So which means the angular velocity is 2.5 radians per second. So after that, we've said that using F is equal to m omega square r, the mass is 16, times the angular velocity is 2.5, so that will be squared, times the radius is 3.2. So that will be 16 times 2.5 square is 6.25 times 3.2. So if you do the math, 16 times 6.25 times 3.2, you will still get the same answer, 320 newtons as the centripetal force. A body moves along a circular path with a uniform angular speed of 0.8 radians per second and at a constant speed of 4.2 meters per second. Calculate the acceleration of the body towards the center of the circle. Solution: the angular speed or velocity of the body is 0.8 radians per second. The linear speed or the linear velocity is 4.2 meters per second. So the question is asking us to find the acceleration. Well, to find the acceleration, we already know two formulas. Either we use acceleration is equal to v squared divided by r, or acceleration is equal to omega square r. But there is also another formula, which is acceleration is equal to omega times v. I will show you how that is derived. So if we want to use the previous formula that we know regarding acceleration, it means we have to find the radius because the radius is not given in the question, right? So let's try to do that. We know that v is equal to omega r, right? So using that, we can be able to find the radius. So if v is equal to omega r, by dividing both sides by omega, we can be able to make r the subject of the formula. So that is r is equal to v divided by omega. So what is the linear velocity? It is 4.2 meters per second divided by what is the angular velocity? It is 0.8 radians per second. So by doing that division, we will have 5.25 meters as the radius. So since the radius is known, we can use any of the formula that has radius to be able to calculate the centripetal acceleration. Okay, any of them will work. So using acceleration is equal to v squared divided by r, that will be the linear velocity is 4.2, so we will square that, divide by r, we calculated it as 5.25. So 4.2 square is 17.64 divided by 5.25. We will have 3.36 meters per second squared as the acceleration. So what if we want to use the other formula? Using acceleration is equal to omega square r. The angular velocity is 0.8. So we will square that, multiply that by the radius is 5.25. 0.8 square is 0.64 multiplied by 5.25. We will still have the same answer, 3.36 meters per second squared. Okay? All right. But like I told you before, acceleration can also be omega times v. All right, so how do we prove that? Well, if we use acceleration is equal to omega square r, and we know that from v is equal to omega r, we can make r the subject of the formula by dividing both sides by omega, right? So in that case, omega cancels omega, and r is equal to v divided by omega. So if we substitute that into this equation, that is going to be acceleration is equal to omega square times v divided by omega. So acceleration is equal to, if you have omega square divided by omega, this will cancel, right? So we'll left it 1 omega. So therefore, acceleration is omega v. Okay, so this is how acceleration is equal to omega v. Again, if we want to use this formula to find the acceleration, so acceleration is going to be equal to the angular velocity is 0.8, multiply it by the linear velocity is 4.2 meters per second. So 0.8 times 4.2, you're still going to have 3.36 meters per second squared. All right, that is centripetal acceleration. A disk moving from rest takes 4 seconds to reach its constant angular velocity of 3.6 pi radians per second. Find its constant angular acceleration. Solution. Here we are asked to find the angular acceleration. Okay, this is different from centripetal acceleration. Angular acceleration is represented with the symbol alpha, and by definition, it is the rate of change of angular velocity. So that is going to be change in the angular velocity divided by the change in time. So when we talk about change, it means that you are going to have two different extremes, if you like. So therefore, the angular acceleration alpha will be equal to, let's say we have initial and final angular displacement and initial and final time. So that is going to be the final minus the initial. Okay, so let's say the final is omega 1, then that will be minus the initial, let it be omega 0, then divided by the final time, let's say t1, minus the initial time t0. In some books, they will use 1 and 2. In some books, they will use 0 and 1. Do not confuse yourself. Just remember that the larger value is always going to be the final. Okay? So omega 1 is the final angular velocity. Omega 0 is the initial angular velocity, the time 1 will be the final time, and time 0 will be the initial time. Okay, so that is if you are using 0 and 1. But if you are using 1 and 2, it means 2 will be the final situation, while 1 will be the initial situation. So you will not have a problem with that. Okay, so if the body is moving from rest, we know that the initial situations will be 0. Okay, so which means the initial angular velocity will be 0 radians per second. The time at the initial situation will also be 0 seconds, right? So what is omega 1? That is what is given. It is 3.6 pi radians per second. 3.6 pi radians per second. And the time 1 is 4 seconds. So if the initial time is 0, it means you can just simply say that the angular acceleration is equal to omega 1 minus omega 0 divided by just simply t, where t is the difference between the final time and the initial time. So t is actually t1 minus t0. Okay, it is the total time between the two intervals. So that is going to be alpha is equal to omega 1 is 3.6 minus the initial will be 0, since the body starts from rest, divided by the time is 4 seconds. So alpha will be 3.6 divided by 4. Alpha is equal to 0.9 radians per second squared. So remember the unit of angular acceleration as radians per second squared, not meters per second squared. Okay, so you have to be careful of that. A drill moving at 9 radians per second reaches an angular velocity of 16 radians per second in 10 seconds. Determine the angular acceleration and angular displacement of the drill. Solution: we have the initial angular velocity as 9 radians per second. We have the final angular velocity as 16 radians per second. The time is 10 seconds, and we are asked to calculate the angular acceleration and the angular displacement. So we know that angular acceleration is equal to omega 1 minus omega 0 divided by t. That is the final angular velocity minus the initial angular velocity divided by the time. So that is 16 minus 9 divided by the time is 10 seconds. So 16 minus 9 is 7 divided by 10. Therefore, the angular acceleration is equal to 0.7 radians per second squared. Okay? I always try to emphasize that you should not confuse angular acceleration with centripetal acceleration. There is one that is a linear acceleration, which is the centripetal acceleration, and you should always differentiate it from the angular acceleration. And in fact, the relationship between centripetal acceleration and angular acceleration is that the centripetal acceleration A is equal to alpha times the radius. So that is the angular acceleration. The second question wants us to find the angular displacement theta. How do we find that? Well, the formula that you have to use is that if you can remember the equation of linear motion, S is equal to ut plus half at squared, we can modify this formula, okay? Since we are not dealing with linear motion, the displacement S will be theta, will be the angular displacement. This is equal to the initial velocity will now be the initial angular velocity, WO, so T, plus half. The acceleration is an angular acceleration, so we have to use alpha, then T squared. This is the formula for angular displacement. Therefore, using the angular displacement is equal to the initial angular velocity multiplied by time plus half multiplied by the angular acceleration multiplied by t squared. If we substitute the values, what is the initial angular velocity? It is 9 radians per second, so that will be 9 multiplied by the time is 10 seconds plus half multiplied by the angular acceleration is calculated as 0.7, then multiplied by 10 squared. So 9 times 10 is 90 plus half multiplied by 0.7 multiplied by 10 square is 100. So 2 here is 1s, into 100 is 50. So what do we have? We're going to have 90 plus 0.7 times 50. So that is 90 plus 0.7 times 50 is 35. And 90 plus 35 is 125. So that will be 125 radians. Okay, that is the unit of angular displacement. If you want, you can express it in terms of revolution or in terms of degrees. Okay, but the answer usually should be in radians. An object completes 42 rotations in 1 minute. The distance from the center of rotation to the position of the object is 50 centimeters. What is the frequency of rotation, the angular velocity, the tangential velocity? Solution: the number of rotation is 42 rotations. So 42 rotations have been performed in 1 minute. Okay, so that is the total time is 1 minute. That is the same as 60 seconds. It says the distance from the center of rotation to the position of the object is 50 centimeters. So that is the radius. It is 50 centimeters, which is the same as 0.5 meters. Okay, by dividing 50 by 100. So let's say this is the center of rotation. This is the position of the object. For a body that is moving in circular motion, the distance from the center to the position of the object is the same as the radius of the circle. Okay? So that is how we interpret it. The first question is asking us to find the frequency. We know that it is equal to the number of rotation divided by the total time. So that is going to be 42 divided by 60. 42 divided by 60 is 0.7, so that will be 0.7 hertz. Okay, so the second question is the angular velocity. The angular velocity is equal to 2 pi f. So that will be 2 times pi times 0.7. That is going to be 2 times 0.7 is 1.4. So that will be 1.4 pi radians per second. So we can leave pi in our answer, okay, unless the question states otherwise. Okay, but since the value of pi is given as 22/7, so which means we're going to have 1.4 times 22/7 radians per second as the angular velocity. 1.4 times 22/7 is going to be 4.4 radians per second. Hadn't been we were instructed to leave pi in our answer, this is the way we would have expressed it, okay? But since pi is given as a numerical value, we have to simplify to this extent. The third question asks us to find the tangential velocity. That is the same as the linear velocity. Question 3. To find the linear velocity, we use v is equal to omega r. So what is the angular velocity? It is 4.4 multiplied by the radius is 0.5. So 4.4 times 0.5 is 2.2. So that will be 2.2 meters per second. A disc of diameter 7 meters rotates at 3 revolutions per second. Determine the tangential velocity of the disc. Take pi equals to 22/7. Solution. The diameter of the disc is given as 7.0 meters. The expression 3 revolutions per second is angular velocity. Okay? So, which means omega is 3 revolutions per second. We want to find the tangential velocity v, and pi is to be taken as 22/7. To find v, we know that v is equal to omega r, but omega, that is the angular velocity, has to be in radians per second, not in revolution per second, okay? And we have to find the radius from the diameter. To find the radius, we know that radius is equal to half the diameter. So that is going to be 1/2 times the diameter is 7.0. So half of 7.0 is 3.5 meters. So we are able to find the radius. But how do we solve the problem of the angular velocity that is in revolutions per second and we want to convert it to radians per second? So the angular velocity omega is 3 revolutions per second, and we want to convert it to radians per second. So time is already in the unit that we want, it is in seconds, but the angular displacement is what we have to change from revolutions to radians. So what is the relationship there? We know that 1 revolution is equal to 2 pi radians. So if that is the case, what will be 3 revolution? That will be equal to x. What we do, we cross multiply, and if we cross multiply, that will be x times 1 revolution is equal to 2 pi radians times 3 revolution. To find x, we divide both sides by 1 revolution. So revolution cancel revolution. The same thing here. So what do we have? X will be equal to 2 times 3 is 6. So that will be 6 pi radians. Okay. So since the time is in the same unit, we can therefore say 3 revolutions per second is equal to 6 pi radians per second. Now it means the angular velocity is equal to 6 pi radians per second. So if that is known, knowing that v is equal to omega r, what is the angular velocity in radians per second? It is 6 pi, okay, radians per second. So that is going to be multiplied by the radius is 3.5 meters. So 6 times 3.5 is going to be 21 pi meters per second. So, but we are given that pi is equal to 22 over 7, right? So if we substitute that, that will be 21 times 22 over 7 meters per second. So 21 times 22 over 7 is 66. So our answer is 66 meters per second. And that is the linear velocity. The drum of a washing machine of radius 150 centimeters spins at 840 revolutions per minute. Calculate the linear velocity, the acceleration towards the center of the drum. Take pi as 22 over 7. Solution. The radius of the drum is 150 centimeters. That is the same as 1.5 meters. 840 revolutions per minute means this is the angular velocity. So the angular velocity omega is equal to 840 revolutions per minute. We are instructed to take pi as 22 over 7. The question wants us to find the linear velocity and the acceleration. Okay, that is the centripetal acceleration. So what do we do? Here, the angular velocity is given in revolutions per minute, but we want it to be in radians per second. Okay, that is the standard unit that we will work with. So the first thing is we will convert the angular velocity from revolutions per minute to radians per second. Okay, we have 840 revolutions per minute. How do we convert this to radians per second? We have done this in our previous videos. You could find it in the channel. When converting angular velocities from one unit to another, it is important to note if the unit of time has changed. The unit of time has changed from minutes to seconds. So we will first try to convert time from minutes to seconds. We have to remember that 60 seconds is equal to 1 minute. So if we should express that in fraction, it's either we say 60 seconds divided by 1 minute or 1 minute divided by 60 seconds. So we will ask ourselves now, which of these should we use? Well, if you have minute here as a denominator, what you have to use is where minute is a numerator, and that is going to be this. So we will multiply 840 revolutions per minute by 1 minute divided by 60 seconds. So with that, minute will cancel minute. So now we're going to have 840 revolutions divided by 60 seconds. So 840 divided by 60, that is 14 revolutions per seconds. So the angular velocity now is in revolutions per second. Actually, when you have per second here as your answer, it means that the frequency is 14. Okay, what is frequency? Is the number of revolutions performed in 1 second. So here we have 1 second and the number of revolutions is 14. So it means the frequency is 14 revolutions per second, or simply 14 hertz. But now we want to continue to express our answer in radians per second. Okay? So at this step, the angular velocity is in revolutions per second. We still have to convert to radians per second. Okay? So we know that 1 revolution is equal to 2 pi radians. What is 14 revolution? That will be equal to x. We cross multiply, and if we cross multiply, we will have x times 1 revolution is equal to 2 pi radians multiplied by 14 revolutions. So to find x, we divide both sides by 1 revolution. 1 revolution. That is, here will cancel out. Revolution will cancel revolution. So x is equal to 28 pi radians. Okay, so which means we have been able to convert the angular displacement from revolution to radians. Okay, so therefore we can say that 840 revolutions per minute is equal to 28 pi radians per second, and this is what we want. So our angular velocity is 28 pi radians per second. Now we can move on to answer our question. All right, the first question is asking us to find the linear velocity. The linear velocity is equal to omega r So what is the angular velocity in radians per second? It is 28 pi, okay, radians per second. Then multiply it by what is the radius. The radius is 1.5 meters. So 28 times 1.5 is 42 pi meters per second. So if we want to substitute the value of pi, that will be 42 times 22 over 7 meters per second. 42 times 22 over 7 is 132 meters per second. But we can also use an alternative formula, that is V is equal to 2 pi FR. I hope you can remember this formula as well. So what is the frequency? Like I told you previously, frequency is the number of revolutions in 1 second. So here is already 1 second. If this is 14 here, it means that 14 revolutions have been performed in 1 second. So actually it is telling you the frequency. So we could use 14 here as our frequency, okay, when the unit of angular velocity is in revolutions per second, not radians per second, okay? Be careful of that. So we will say V is equal to 2 times pi times the frequency is 14 times the radius is 1.5. That is going to be 2 times 14 times 1.5. We will have 42 pi, as you can see. And if we substitute the value of pi, that is 42 times 22 over 7, we will have 132 meters per second as our linear velocity or tangential velocity. Okay, so moving on to answer the second question, it wants us to find the acceleration, okay, the centripetal acceleration. So we know that we can use acceleration is equal to v squared divided by r, or acceleration is equal to omega square r, or we know that acceleration is equal to omega multiplied by v. Any of these formulae is supposed to work, okay? So if we use acceleration is equal to v squared divided by r, the linear velocity is 132. So that will be 132 squared divided by the radius is 1.5. We will have acceleration as 11,616 meters per second squared. All right. So again, if we want to use the angular velocity, acceleration will be equal to what is the angular velocity in radians per second, that is 28 pi, right? So that will be 28 pi all squared multiplied by the radius is 1.5. So that will be 28 square is 784 pi square times 1.5. So 784 times 1.5 is 1176 pi squared. If we substitute the value of pi, we'll have 1176 times 22 over 7 all squared. So that will be 1176 times 22 squared is 484 divided by 7 squared is 49. So 1176 times 484 over 49, we will still have 11616 meters per second squared. The other formula is acceleration is equal to omega times v. So if we use that, acceleration is equal to the angular velocity is 28 pi, right? That is in radians per second. So 28 pi multiplied by the linear velocity is 132. So that is going to be multiplied by 132. So 28 times 132 is 3696 pi. If we substitute the value of pi, that will be 3696 times 22 over 7. When you do that math, you will still have 11616 meters per second squared. So any of them can work, all right? You don't need to show all the work and just use only one method or one formula to get your answer, all right?